Hello, I'm John, and this video is a little bit different to the usual ones about tractors. It's about generators this time. In particular, these clone generators, of which there are many on Facebook Marketplace, and most of them are advertised as made by Perkins, which they plainly are not, and being 26 kVA output, when they're probably about 5. They possibly struggle to reach 5. Here's 3 examples of the Perkins 26 kVA generators that are advertised. I suppose I shouldn't let it get to me really, but I'm absolutely appalled that Facebook allow it. This last one shows the rated current as 26 amps and the rated speed as 1500. But however, for reasons I'll explain in a bit, I use in particular this little 3-phase one a lot. And it's just burnt the generator out lately, and I've had to replace it with the only one I could get, which is a Hyundai. And I'm really looking for advice and hoping against hope that somebody knows how they are rewound, the way to do it. I've got a couple of stators now which need rewinding. It's not economic to do them. I've talked to few places locally that do rewinds, and they just said buy a new one, it's not worth them even getting involved. There's plenty of videos on YouTube about rewinding them, particularly the single phase ones like this, but unfortunately most of them are in Hindi or made in Indonesia, and even the ones with subtitles I can't understand them at all. Made in Indonesia in particular, the subtitles said hey hey before each sentence, and then it was just gobbledygook to me. It didn't make any sense. So I'm rather hoping that somebody knows. There's a channel called James Condon, who makes, he's a very popular channel. He makes videos about repairing these little generators, and he's been very lucky. I'm quite envious of him because all the ones that are faulty that he deals with are simple things like brushes or something wrong with the engine, or at worst the AVR. None of them have burnt out and need rewinding like these do, unfortunately. If you're listening to this and hear about James's channel, you'll know that I've passed it okay with him to actually mention him. I'm going to upload this video and then let him look at it and see whether he minds me asking, because hopefully he might give me a link to his hundreds of viewers, hundreds and thousands of viewers he's got, and somebody might know something and be interested enough. I'm just very, very curious how it's done. I can't believe it's rocket science. So there you go. I'll have a look, show you around the rest of the generators and try and explain why I use these ones now. I bought this little single phase one as a non-working machine. The engine ran, but the generator itself, or the alternator, had actually burnt out, and I replaced it with the cheapest one I could get, which was probably a mistake. And that one, as I've now realised, hasn't actually got an auxiliary 12-volt supply, which is this. I think it's used for battery charging. It says DC 12 volt, 8.3 amps. And I think the idea is you can use it to charge your battery if you need to, or to take a 12 volt supply off it. And I found out that the oil fail-safe mechanism doesn't work if that 12 volt doesn't exist, which it doesn't. So I'd quite like to try and get that. I've hauled out a catalogue of disaster and put on the workbench so you can see them, of previous ones that have gone wrong. These are the front end of each generator. They are the rear end that holds the bushes. There's 2 perfectly good rotors there, one for single phase, one for 3-phase, although to be honest I don't think there's a lot of difference in them. These ones are the stator. This one is a single phase one, which I've had to go at pulling apart. You can see where a lot of the wires are burnt. And that actually doesn't look too bad at all. I think it's fairly straightforward, the mains windings. It's just where the exciter coil goes and stuff like that, and in the auxiliary 12 volt coil if they've got one. This is the one that most recently burnt out, which was my little 3-phase, which I had used for absolutely years. The problem I think was caused, it was my fault in a way for not noticing quick enough. that had a bad connection on the circuit breaker, and that sparked and went ahead, and I suppose that induced enough voltage to burn through the main windings. They shorted out with the one of the other coils, again like the exciter or the 12 volt auxiliary coil. That one's a 36 slot. The single phase doesn't use anywhere near as many, and that looks quite straightforward. It seems to go from one to the other. I might perhaps take it apart and see if I can unwind it and make any sense of it, but it really would be nice to know, if anyone does, how they are supposed to be done. The reason I use the little three-phase generator so much is I've got a lot of three-phase machinery that runs off it. Even this little compressor that's got 3 horsepower, which is a DOL direct online start one, and the little generator will fire that up without any problem at all. Other machinery like this bandsaw, that needs very little power as well, just enough to drive the band and also the water pump on it for cooling. Things like this small lathe, which is a Colchester Bantam, I could put a single phase motor on that. We haven't got 3-phase obviously here, that's why I go to all this trouble. But I'm reluctant to put a single phase motor on because with the 3-phase you get 2 lots of speeds. Zoom in there, you can see the 2 different colours, red and blue, and that's the different speeds depending on how you have the main set down the bottom there on that switch. So I don't actually know, but I assume that the motor will either run at 1500 or 3000 RPM. There's other machinery like this old shaper, which I think are quite sought after now. You couldn't give them away at one point. I'll put some metal in it and just do a little demonstration of how it works later on. It's quite relaxing to watch them cutting metal. But anyway, that's got a 5 horsepower motor on it. And with a soft start, which I have put in it, the little generator will start and run that, no problems at all. This is an old Victoria milling machine, and again that's 3-phase. Everything I've got here really is 3-phase. That's got a 5 horsepower motor as well. That's got a soft starter on it, which does make the little Jenny smoke a bit just initially, but that will start and run it okay. The lathe next to it, which we've had for many years and which is why we had to buy the biggest PTO driven generator initially, the little generators won't even look at that, even with a soft start. I think that drives quite a lot of gears and the oil pump and all that, rather than the motor just spinning up on its own, and that needs a big generator to make it move. So this is the PTO generator that I first had. I dread to think how many years ago. There's a hole in the wall and the PTO shaft goes through there and you hook a tractor up onto it. The plate on the Jenny is over the other side of it between the wall, so I can't remember actually what it is and can't easily look at it, but it's definitely 50, might even be 60 kVA, so that will power just about anything. But unfortunately having a tractor standing outside running is a bit of a nuisance and just a waste of power really. That came with all the old equipment. There's an earth leakage trip up there, and this is a frequency counter, that orange light. I put that in the window so you can be outside and actually set the tractor to the right revs, so you know you're getting 50 hertz or as near to as possible. Then I bought this engine in bits, which is a Cummins A2300, which I think means 2.3 litre. I think that came off the oil rigs or somewhere, and that had been partially dismantled, but that runs a treat. And I made up the frame for it, as you can see, and I actually bought a Stamford, is it? Yeah, alternator on the back. I think that's 30 kVA as well. And it's got one of these Chinese electronic governors on it, this thing, which I think was about 100 quid. And the one that they've copied is such a shame. The genuine one is about 1,000, so 10 times as much. Having said that, I can't get the thing as stable as I would like, but it does work. And I really need somewhere else to put these. But again, using this is just a waste of power. That uses too much diesel. I made the frame and I made the diesel tank in the bottom underneath it all. and unfortunately I slipped up really there because it only holds about 20 litres or something, and if this thing is doing any work at all, that soon chews through it. Whereas the beauty of those tiny little Chinese clone generators with a 400 odd cc single cylinder engine, they're very, very economic. That's the only good thing you can say about them. I only took a few stills when I was making it. I had no thoughts of making a YouTube channel then. That's an engine mounting off a boat on the box section frame. That's obviously the new alternator on the back of the Cummins engine. And the rest of them, I think, are just the little Chinese throttle control. I did make a video earlier on just to show some friends, with no thoughts of doing YouTube really, but I uploaded it to YouTube to make it easy for them to see, which is down in the rest of my videos if you do want to see it. The only alternator I could find for it was one made by Hyundai, and the firm were very good. They said they didn't think it would fit, but if I tried it and didn't damage it, they would take it back again. So this is a short video of what I found in the end about making it fit. Start off with the new front piece of the alternator and the back one, and the old one rather, the front one of that. And the good news is that the holes do actually line up. The not so good news is the old one uses thicker. There's a thicker bit, there's 15mm in that one. I've got a nasty feeling these are less. Yep, they are 10.5. So these, I think these are M830s. They'll have to be made into M825s with a hacksaw, because I haven't got any flange head bolts to suit, so I'll just cut a piece off. That's better. They all seem quite a snug fit now. Obviously I'm not using a rattle gun because I don't want to wring the threads off the aluminium. That would be a disaster. So I prefer to do it more slowly and by hand. They're very heavy indeed, these things. The package or the box that came in said about 35 kilos, so they've certainly got some meat in them. It looks like the back feet are a bit wrong, but nevertheless that does seem as though it's going to go up there. I'll have to get a piece of wood for So coming to the end of the video now, and as promised, there's the little oil failsafe circuit, which is quite simple really, although it took me ages to work out how it works. It's got two relays, two capacitors, a resistor and an LED feeding off that. So if you look on the other side, you'll see the circuitry that I copied out on a piece of paper, which I shall show in the next clip. This is my attempt to show how the oil fail-safe circuitry works. All the switches are shown in the released position. Two relay contacts there released, and that's the oil pressure switch, which is shown with an earth on there because it's released. When the engine's running, obviously that opens up. So this is how I think it works. When you turn the ignition switch to on, the live comes in here, 12 volts on here on the brown wire, comes through this normally closed, not operated position relay 2 contact, and it goes straight out again on the blue wire, which operates the stop solenoid and the engine, allowing the engine to run. The relay coil 1 up here doesn't do anything at all because the 12 volt auxiliary supply isn't there until the generator is running. So once the generator starts, get oil pressure, the oil switch opens and the 12 volt auxiliary supply appears on this rail on the red, but that does nothing because that switch is broken. So the only thing that happens is when the oil pressure fails, should it fail, the engine loses oil pressure, this switch makes, you've already got the 12 volt auxiliary supply there, and the simple circuitry just operates relay coil 1 like that. So relay coil 1 operates its own contacts there. They're only just a make, the brake part isn't used at all, and that then puts the live wire from the ignition through to operate the coil of relay 2. Relay 2 operating moves this contact here from the brake position to the make position, which immediately disconnects the stop solenoid, stopping the engine. But not only that, the changeover part of the switch puts ignition live from the brown wire through there to maintain relay 2 operated. And that lights obviously the LED as well because you've got 12 volt supply on there. So that's how I think it works. Interesting to know if you think I'm wrong. I don't mind being wrong if someone can explain it. But there we are. It took quite a lot of head scratching to get that far to try and work it out. I've bodged up this little circuit to try and explain how I think the oil pressure fail circuitry works. So I just turn it on. This blue LED, that simulates the stop solenoid on the engine. So if that's on, the solenoid is alive and lets diesel through to the injector. Obviously, if it's off, the engine would stop. This is the oil pressure fail lamp. This switch here, which came off a lawnmower, that simulates the oil pressure fail switch. So when the engine's running, that should be disconnected. When it's stopped, it should take this yellow wire to earth. The engine has a 12 volt auxiliary circuit, which the circuitry here uses when the engine's running. This wire becomes live from the auxiliary battery charging circuit. So we simulate that by sticking those two wires together. So the engine's running quite happily. Should the oil pressure drop, click, solenoid releases, light comes on. Obviously this would go off because the generator by then has stopped turning, but the solenoid is still dead and the lamp is still on. The only way to stop it is to turn the ignition off, and you'll eventually, there's big capacitors, a couple of electrolytic capacitors across that relay, which make it hang in for a bit. You'll hear the relay go. There we are. And then that all should reset itself.